Hey everyone, I'm Sandeep. I'm the CEO for CodeStory, and I'm here to tell you that Copilot and prompting is dead. I imagine everyone's using an editor. If you're not, you've probably heard of Copilot. You're probably used to prompting, writing prompts for AI to write code, all of that. So why am I able to say this? I was the tech lead for Test Infra and DevX back in Meta, and then we are a group of 4 building a new AI editor. There's so many of them out there. Z1, Cursor, VS Code by itself has AI features. And what we want to tell you more about is how the world is going to change in the coming months and years, and what we can, what are the innovations we can do on top of that. So first of all, we are going to show you a new kind of UX, which is anchored editing. It's way better than Command K, and of course, way better than Copilot. So this is my editor, which we have been working on. On the right, you can see a bunch of commands like anchored editing, blah, blah, blah. Oh, sorry. Yeah, for sure. Can you see it now? Yeah. Cool. So see the way I'm moving, when you do Command K in any editor, you have to select the right lines of code. If you mess anything up, then the AI is going to write code which is janky. So what we changed over here is that we are looking at the AST of the tree itself, of the code, and you move on top of that. So this is the impl block. I'm going inside, I'm going outside, whatever, right? So that's what we have. And how do I instruct it? So I just do, let's say I do Command K over here, and then I just go add maybe user ID to this. Sorry, it's hard to type and talk at the same time. So comes and goes. This was Sonnet 3.5, by the way. You can see the speed difference is real. So I'm going to stop here, and I'm going to talk more about follow-ups and what they are about. So generally in a code base which is very interconnected, it's not just the fact that you changed a piece of code somewhere. You have things you need to fix to make it all work. So these 3 places, they are using my code, the thing which I changed right now in some way or the other. And I'm going to talk more about how we are going to go about fixing it, but that comes in a bit. So that's anchored editing for you. It's very new, brand new. Get it hot at 8. So now SWE-bench and how we won. No fine-tuned models. I don't think we're ever going to do it. We have faith in frontier engineering and research. And literally what we do at CodeStory is hardcore engineering. Our latest SWE-bench light score is 54.67. That beats the state of the art out there, and it improves on our 43% score, which was, I think, a month or so ago. Maybe more, I don't even remember. Time flies. The reason we are able to do this is because our infra and tech is built on the fact that models improve over time, and the tools we provide to these models need to work for them, and also for the humans, right? So we have this concept of OOMs. I'm sure you must have heard about OOMs. If you have not, it's called orders of magnitude. So every time a new model drops, it's an order of magnitude improvement. And it's our job as developers and builders for code generation to bring about the right UX to make that OOM work for you. Now, what are our agents? We are going to talk about multi-agents, but first to ground it a bit, what are our agents? Our agents is a single code symbol. What does that mean? It means that in this file, this function is one code symbol. This function is one code symbol. All of these are individual code symbols. And that's how we are able to give every agent a small unit of work which it can focus and work on. If you have written Rust, this is Rust by the way, if you have written Rust before, you would know that sometimes what tends to happen is that you have implementation of the same code written all across different files. We take care of that, so you don't have to worry about it. The same holds for Golang. You define a class somewhere, the implementations are all over the place. We understand it because we work with the language server and we work with the dev tools moreover. So we use the editor moreover to help us detect these agents and where they belong. And that's how our agents kind of work and talk to each other. Now the tech powering our agents are literally dev tools present in the editor. Why did we build on top of VS Code? A, skill issue. B, VS Code is open source. More on the skill issue, otherwise I would have built something like Z, to be honest. But inside the editor, you have extensions, you have debuggers, you have test runners, you have the language server. You have a bunch of tools which I think all of us spend quite a lot of time setting up, because our editor works for us. It's a shame that all these AI tools out there either go on the cloud or they go oh, we can create an extension and you just add it on top of the experience you have. We want to work with the experience you have already created. That's why we are big on like using the tools inside. So when we were running SWE-bench, what we did was we created a mock editor. This is the terminal which I'm showing you over here is literally the editor the agent had access to. You can see there's some like go to implementation handler, apply edits handler, file open, blah, blah, blah. These are the ways the agent interacts with the editor. It sends it over an RPC calls, tells it that, hey, I want to do this operation on this symbol, and we just take care of translating it. It's super easy. And to be completely honest, VS Code team has done a great job of exposing these APIs. When they don't, we just hack it because we own the editor. So kudos for us. Anyways, coming to multi-agents grounded in the code base, we are not just correct, but also fast. And the other important property here, which kind of emerges when you have a swarm-like architecture, is an individual agent which is smart enough can work together to create something amazing. Now, coming back to this part, I'm going to click something called make follow-ups. This was done today, so let's see what it does. Okay, cool. Well, this does not, I think I'm not able to click it. Well, that's kind of expected, still new, blah, blah, blah. We go here, okay. It's going to start making changes. Well, it's bugging. Oh, wait. Well, okay, I'm going to exit this. But you can see that it started making changes to all over the place in the code base where things were broken. And it will also go beyond the file in a bit. It takes a while because the LSP is like garbage on my laptop. But what I wanted to emphasize was that we use the tools in the editor called the language server. We look at all the, oh, it's already going, cool. We look at all the references, go everywhere it is being used, which is a lot of places, and make changes there individually. This all happens by just clicking a command. So instead of you manually going everywhere in the code base and doing, using Copilot, you'll probably go to the location, you will place your cursor, it will make an edit, do all of that jazz. We kind of do it on our own. And we are correct because we're using the LSP, and Sonnet 3.5 is a good coding model. So it kind of works for us. Anyways, coming back to this, editing your code base, right? So people have talked about using vector search, hybrid re-ranking, creating keywords. We also do a bit of that, but recently we kind of realized that, LLMs are getting smarter. They have a larger context window which they're able to utilize. And as in a previous talk, which was mentioned that after 60K tokens, it kind of falls off. We have seen that. So we created a plan, what's the right way to call it? We created like a agentic search experience, which means that we use the repo map, which I also wanted to show you how it looks like if I have it open. Kind of like this. Oh, sorry, it's also small. Give me 1 second. There we go. So what we do is like we create an outline of each of the functions and where it's located. And to be completely honest, this is something which if you have used Aider ever does the same. We kind of like borrowed that, ported over it in Rust. Yeah, so that's kind of it. They did a lot of hard work, so we can just rely on it. But we do that, and then we also give it the file tree structure. We give it like all the LSP action, like go to references, go to definition. So our agent is able to crawl the code graph, create a scratchpad of what's important, take note of it, and then start doing the edits and come up with a plan. And for editing itself, we rely on search and replace blocks. It's not exactly git diff. Search and replace is, let me see if I have an example. Oh, there we go, cool. Looks kind of like this, which is you have a search block like the code you want to replace, and then you have the replace block. The reason it tends to work in code bases, and especially with Sonnet, is because even if there are repeated code which looks the same, Sonnet is smart enough to add in surrounding code blocks to the search block. So all the replacements are unique. And to give you a number on this, we have done approximately, I think like close to 50, 60K search and replace blocks. I think the number was 50K yesterday. It might be 60K today. I didn't check, but none of them have any single errors. So it's a very concrete method you can rely on. And this also creates a building block for us to work on top of. And then we always provide the correct context. How do we do that? Long context, right, for the win. And we have other OOMs which have come our way, which enable long context to be used. So we don't need to rely on wonky embedding or retrieval. We can be a bit better than that. And we don't use any vector search. It's too mid. I never got the idea. I'm never going to use it. So there we go. Now, agentic editing, right? So I want to show you a bit about that, like what it really means. So let's say we have these two files. We have a bunch of routes which we use to talk to and some code over here. I'm gonna, oh, it's already added. Well, yeah, that's fine. Give me a hot sec while I write the prompt. Can you, for you guys in the back, can you add code editing stop end points similar to probe request stop? Make it Agentic. If the bug fix we did today works, then this should work, but we'll find out. Let's see. So what it's trying to do here, like the agentic flow is a bit different because unlike anchored editing where you give it like the exact context where you want to do edits, oh, there we go. Wow, that was fast. It has to do a bit of planning, which is, coming up with a bunch of steps and what it wants to do. And then it starts making edits like in the code somewhere. This file is already in unsafe place. So yeah, there we go. It wrote that code, probably has written this part. Okay, cool. It's writing this part right in front of you. That's also done. It's gonna make the last change for me over here, which it should do in a minute, unless it doesn't do it. I don't know. We'll see. Are you gonna do it? Well, it stopped. Well, it should do it. But the idea which I wanted to show you here is that we do a bunch of planning so it can do cross-file edits. And that's a pretty stable experience until it breaks, which it did, which is fine. Those are bugs we can fix. But yeah, that was like another experience I wanted to show you. Now, why is all of this possible, right? The reason why it's possible is that this year has been kind of like an year of booms if you think about it. So Sonnet 3.5 dropped, which is the first LLM which I believe to be kind of agentic, like it's able to plan ahead, it's able to say that it wants to create like a sub function instead of just adding more code to you. It wants to delete something and refactor it out. It's pretty good. Then the other big thing is prompt caching. What does that mean? It means that we give Sonnet a bunch of files, we ask it to make a lot of edits, and it's super fast. You have seen like the experience here feels super fast, right? Like it's not slow or anything. It's like able to do the things it wants to do. So I tend to like it for that, and I'm actually using AI a lot more because of the speed and velocity of it. And the last thing is tokens are too cheap to meter. Whatever experience you're creating now, which feels expensive, drops in price by 50 to 60% year over year. Why not use the frontier model and build on that? Like, seriously, I wouldn't know. Like one of the things a person who I really respect told us was that go to where the puck is going to be, not to where the puck is. And we kind of embody that at CodeStory. Now, full throttle into the future, right? So the last thing which I want to show you, which I personally found really impressive, and we got it working last night, was, I know it's a very mid-rig prompt, but come on, bear with me. Cool. So what it's going to do is, there is a lot of code. I think like, yeah, this is an average file at CodeStory, around like 1,000 lines of code. It's going to take a while because the prompt is not warmed up or anything. But what you'll see happen in a short while is a lot of agents are going to come up and start editing the code at the same time. So this file is going to be written by a lot of agents at the same time. Wait, why is it not starting up? Give me 1 second to look at this. Oh, it is. Yeah, cool. But yeah, while it does it, 1 second. Oh, yeah, it errored out. Okay, cool. Well, give me 1 second. Let's see. Oh, cool. Yeah, it's going to start up in a bit. But the idea here is that like, because we are using multiple agents, we are able to go through these 1,000 lines of file in like a very short unit of time. And that enables us to kind of like do a lot of parallelized work. So the latency is very low. We are using the best intelligent models, Sonnet 3.5 right now. Oh, this is constantly failing. Well, I came prepared. So we have the final video, which I recorded, so I can show you that. Because I knew something like this happens when you do a demo, right? So, oh wait, is that the one? Shit. Not that prepared. Final. Not this one as well. Oh yeah, there we go. Yep, that's got to be me. All right. So It's gonna start up. So this is what happens. I was looking at the wrong file, but what you're seeing here is a lot of agents come up at the same time and start writing and editing code. And it happens, at the same time, like even before you can notice, code is being written at the speed of thought in a way. And the cool part here is it's a single file. VS Code generally does not support editing at the different locations in the same file. We hacked around it. So there we go. And the reason why I wanted to highlight this is also because of the fact that that's what the future is going to look like. You will have a lot of AI engineers writing code for you. AI typically allows anyone to write code. The sad part is writing code is not what software engineering is about. It's about like maintaining the connections, thinking about the overall picture, making sure things are, documented, things don't break, etc., etc. What we think the future will be is that engineers will have a team of agents in their editor, like what I was trying to demo to you and like the recorded video I had. And we as engineers will be orchestrating agents. So that's all I have for today. I think I'm running out of time. So thank you guys and if you have any questions, do let me know.